In this concept video, we're going to be discussing how to solve for sides and angles in a right triangle. We've done a little bit of this before, and you might remember some of this from a previous math class. But I want to draw you into this entire concept here together. And one thing that we need to do when we label these triangles, it's a convention that exists in mathematics, is we're going to label the angles with large, or capital, I should say, letters. And it doesn't really matter where the A, B, and the C go, but we'll keep with the Pythagorean theorem here, and we'll make the right angle angle C. And then what you do is you look across from that angle, or the side that's opposite of it. So the side that's opposite the 90-degree angle is going to be the hypotenuse here, and we'll use a lowercase letter for a side length. Okay, so uppercase letters indicate angles, and then lowercase letters will indicate a side length. B then must be across from B, or opposite of it, and then across from A, the small a, or the distance here, will be letter A. Also note that A and A here, the angle A is not formed by A. So angle A is formed by C and B. So if you're having a little trouble figuring out which one's the opposite, you can just look at what lines, or what legs, or what sides of the triangle, I should say, form this angle, and the one you're wanting to label with the same angle is just not the one that forms the angle. Alright, we're going to talk about some useful relationships here, and some of these again might be some repeats for you, but it's nice to have them all written down in one piece of notes. So one thing we can use with a right triangle is a squared plus b squared is equal to c squared, when A and B are the legs and C is the hypotenuse. That's important. So we've got the old Pythagorean theorem. If we take a look at the angles, we can look at angle A and angle B here, and we know that angle A plus angle B plus 90 must be 180, or angle A and B must add to, let's see here, we'll do angle A and angle B, must add to 90 degrees. So they are complementary. Let's use some other ones. We've got the sine of angle A. So if we do the sine of angle A here, that is going to be A over C, opposite over hypotenuse. And then if we looked at the sine of angle B, that would be opposite over hypotenuse, or B over C. So in a triangle, it just depends on which angle you're looking at. That's actually very important when you set up your ratios. And we've got the cosine of angle A. Cosine would be adjacent, which is B over hypotenuse C. And if we switch angles, we look at cosine of B, we've got the adjacent, which is A over C. And then the tangent is another one, and of course you could set up your other trig functions as well. But normally in a right triangle, when we're solving for sides or angles, we don't usually use those other trig functions, because the sine, cosine, and tangent are normally enough. Tangent of A then would be opposite over adjacent, so A over B. And then the tangent of angle B, we're going to define that here to be opposite B over adjacent, which is A. So these are just some useful things. Also, I'm going to write this little note down here too. When solving for an angle, use the inverse. Use the inverse. So if you don't have either one of these angles, you're going to need to use the ratio of the sides to solve for the angle, and you need to use the inverse when you're solving for an angle.